Hey guys, and welcome back. My name is Miss Danielson, and today I'm taking you through a lesson on rounding to place value. First, we'll go through a lesson including some examples. If you missed out on our lesson on place value, you may want to check that out first, so I'm linking it down in the description box below. Let's get started. First of all, what are we going to learn today? We are going to learn about rounding to given place values, which is why knowing your place value names is important, and determining the degree of accuracy to which a value may have already been rounded, as well as setting up number lines for rounding. So to start us off, let's just clarify why we round. Sometimes we have really long numbers, which could represent a really big value, or it could represent a really small value. Let me show you what I mean. The population of Spain is about this number. Now, if you were with us for place value, you would know that this is 46,704,314. Now that is a big mouthful. There are a lot of people in Spain, and this is a very long number. I could simplify this number or round this number to make it easier for me to say and easier for me to convey. Here's another number which is very long, but it's very small. This is the width of a hair. The width of a hair is 0.035128 millimeters. That's not even 1 millimeter. That's not even half of a millimeter. In fact, using our place value knowledge that we learned last lesson, we should be able to name this number by counting the place values after the decimal. So there's 1, 2, 3, 4, 5, 6 place values after the decimal. Starting with the tenths position, this is the tenths, hundreds, thousandths, tens of thousands, hundreds of thousands, millionths. So this is some number of millionths. We just named the number after the decimal point. So that's 35,128 millionths of a millimeter. That's tiny. And it's very long for us to say and confusing for us to say. Let's have a look at another couple of examples. The elephant population in Africa, for example. Suppose we were told that in 1979, the elephant population in Africa was 1,300,000. Now, I doubt that that's exact. Maybe there's 1,300,001. I doubt it was exactly 1,300,000. I bet this number has been rounded. What place value do you think it was rounded to? I'm guessing the hundred thousands because that's the highest place value that's not a zero. And all of the place values to the right of that have been made a zero. So maybe this was originally 1,300,000 with some value after it that is less than 5, or maybe it was 1,200,000 with some value next to that, which was 5 or greater. In either case, it rounded to 1,300,000. That makes it easier to say, and it's accurate enough to get our idea across, especially when I'm comparing that with the elephant population 10 years later, 609,000. Now the elephant population has clearly gone down over those 10 years, but I still doubt that the exact population of elephants in Africa is exactly 609,000. I'll bet this value is rounded as well. What place value do you think it was rounded to? It could have been rounded to the units, tens, or hundreds, but I think most likely it was rounded to the thousands. There is no way that this was rounded to the tens of thousands because I have got a value to the right of the tens of thousands position other than 0. So I'm going to guess that this was rounded to the nearest 1,000. Let's have a better look now at how we round and what it means to round. So rounding to place value. When you round to a place value, you are simplifying your answer to some given degree of accuracy. So it's not perfectly accurate, but you're naming how accurate it will be depending on the place value you have rounded to. This is a simplification, but it always causes a rounding error. And when I say rounding error, that doesn't mean that we've done it incorrectly. It just means that when you simplify a value, when it's not completely accurate anymore, there is a difference between the exact correct answer and the answer that you're given. But sometimes there's no way we can avoid that. When our number is very, very long, there's no way we can write it down without rounding it. Let's have a look back at our example about the population of Spain and the width of a hair. Now, 46,704,314 is a very long number to say and write, so we can round it or simplify it to the nearest 10 million and say that it's approximately 50 million. Now, notice the symbol I used here. It's not just an equal sign because they're not exactly equal. It's approximately equal. That's what this little wave on the top of my equal sign means. It's approximately the same. But as I've rounded it or simplified it, I've made a rounding error. That doesn't mean that I've rounded it incorrectly. It just means that my answer is not perfectly accurate. In this case, our rounding error was 3,295,686. Now that's quite a big rounding error. But even by making that big rounding error, I get a pretty good idea of what the population is in Spain to the nearest 10 million. We can do the same thing with the width of a hair. This 35,128 millionths of a millimeter could be rounded to the nearest hundredth, which would make it 400ths of a millimeter. When I round in that way, as you see, it's not exactly accurate. I didn't put an equal sign, I put an approximately equal to sign, and I made a rounding error of about 4,872 millionths of a millimeter. Now that's a tiny, tiny, tiny rounding error this time because I started out with a really small value, the width of a hair. Sometimes our rounding errors are quite big and sometimes they are quite small. Either way, we should always use this symbol to show that our answers are not perfectly exact. They've been rounded. Now, how do we round? In case you're a bit confused about how I got those numbers for the population of Spain or for the width of a hair, let's go through the step-by-step of how we're rounding. First of all, we'll decide which place value we're going to round to. So find the digit that's in that place value and circle it. This could be to the nearest 10, 100, 1,000, or even 10th, 100th, 1,000th, and so on. Then we're going to look to the digit to the right of that place value we've chosen. Look to the right. If the digit to the right is less than 5, then all the digits to the left will stay the same. So that's all the higher place values will stay the same. And all the digits to the right, that's all the lower place values, will become 0. If, when we look to the right, the digit to the right is 5 or higher, so this is including 5, the digit in our specified place value will round up 1. So that's the digit we started with. If we said we were rounding to the hundreds, the number in the hundreds is going to round up 1. The digits to the left, so that's the higher place values, will all stay the same. And the digits to the right, that's the lower place values, will all become zeros. Let's have a look at a couple of examples. So round these numbers to the nearest 1,000. Go ahead and try that for yourself. Now round these numbers to the nearest whole number. That's to the units position. Go ahead and try those. Now round these numbers to the nearest 100. Now notice, to make this easier for you, I've highlighted the place value that you're rounding to in green. See if you can do that for yourself, and then we'll take it up in just a second. Notice that we get to C of example 1, there is no number in the thousands position. That means there's a 0 there. So a 0 with a 4 next up to it, does it round up or does it stay the same? For D, I made that a bit easier for you. I actually put that 0 in the thousands position. If there's a 0 in the thousands position and we're rounding to the nearest 1,000, look to the right Is it 5 or higher? If so, we'll round up the thousands position and make everything to the right zeros. Here are our answers for example 1. Question B is 50,000. We are rounding to the nearest thousand, which is where this 9 is. With a 5 next to it, that 9 is going to round up, and one number higher than 9 is 10. I don't have enough space in one place value to put 10, so the thousands position became a 0, and the 1 from the 10 passed up to the tens of thousands. That made that 4 in the tens of thousands position a 5. Notice that question C became 0 when I rounded to the thousands, because there was a 0 in the thousands position, with a 4 next to it was not big enough to make that thousands position round up. So I've got a 0 in the thousands position, and these zeros in light blue here that you can hardly see, we shouldn't have to put those there, because the whole value is 0. 0 in the thousands, 0 in the hundreds, 0 in the tens, 0 in the units. Question D, however, that had a 0 in the thousands position, had a 7 next to it, so that rounded up to 1,000. So that makes 1,000. There I do need the zeros next to it to show that that 1 is in the thousands position. Answers for example 2 should be relatively straightforward. Rounding to the nearest whole number or the nearest unit, a 7 with a 0 next to it stays the same. Rounding to the nearest unit or whole number, a 0 with a 4 next to it, very similar to question C above. That 0 stays the same. So again, I don't need these zeros after the decimal. I know that the value of this number is 0. Question C, an 8 with a 0 next to it. Don't worry about those 9s there. The digit directly next to the units is a 0. The 8 will not change. It will stay 8. And again, I don't need these extra zeros next to it. I know that 8 is in the units position, so that's 8. Question D, 49 with a 7 next to it. We've seen something similar to this before up here. That 9 is going to round up. One number bigger than 9 is 10. I don't have space to put 10 in just the units position, so I put a 0 in the units position and I pass the 10 up to the tens position, making this 50. Again, we don't need those zeros after the decimal place. Answers to example 3. Rounding these numbers to the nearest 100, a 3 with a 2 next to it will still be a 3. A 9 with a 3 next to it will still be a 9. An 8 with a 7 next to it, that is 5 or higher. That's going to round that 8 up to make it a 9. And question D, in the hundreds position, there was no digit in the hundreds position, so that was 0 in the hundreds position. But 0 with a 7 next to it will round up to make that 1, so that is 100. That brings us to the end of this introductory lesson to rounding to place value. But if you enjoyed this lesson, please join us for our next lesson on rounding to place values and number lines. Until next time, keep practicing, and I will see you soon.